and then we'll talk about what we got.
Well, did we turn it in though? I thought you said
We didn't turn in the homework.
Oh, well, I don't have a TA today, so I'm gonna have to grade it when we're done today. So Ashton's taking the test. All right, let's finish up this chapter. 2.5 is trig derivatives. Did I give you the list? Sine, cosine, tangent, secant, cosecant, cotangent. All right. Okay, so let's look at trig derivatives in, oh boy, you can't see it. That's why. Let me text it out as well. So not prepared for today, but this is my last class for the weekend. Yeah. Yes, Colorado College hockey tonight and tomorrow night. $5 tickets if you're looking for a cheap date. CC Hockey, and they're actually good this year. They play tonight at 7:30, tomorrow night at 7 at the World Arena. And they should actually be pretty good this year. Yeah, $5. Because Alaska Anchorage, really, not a lot of people come to watch Alaska Anchorage. They're not very good, and that's why CC should win both games. In fact, I'm going to be disappointed if we don't win both games. All right, trig derivatives. Last time we told you, for example, that the derivative of tangent was what? The derivative of tangent was what?
Secant squared.
Secant squared x. So here's what we're going to do today. We're going to take a look at these that have a product rule, a power rule, something else involved in. So example number 1. Let's take a look at y is equal to, I don't know. Let's go for x to the 4th multiplied by, I don't know, secant of x. And we want to find dy dx when x is equal to pi over 4. Now, I don't expect you to have tangent, secant, cosecant, cotangent memorized. I do expect for sine and cosine, you could find every radian if we gave it to you. So if you had me for pre-calc or me for honors FST, I made a big deal of converting everything to sine and cosine, and that's how I'm going to teach you to do it. That is certainly not the only way. If you know secant of pi over 4 off the top of your head, feel free to use it. I don't know it. I don't expect you to know it, so I'm going to show you how to get around that today. Now, question I always ask whenever we start a derivative, what blank are we going to use? Not yet. I don't have TA. What rule are we going to use? What rule is this one going to be dominated by? Product rule, right? Because we got something times something else. Now, within the product rule, there's also going to be what? Power rule and a trig derivative, right? There's also going to be a power rule and a trig derivative. Every time you look at these, and just so you know, chapter 3 is when these get complicated beyond words. You should always look and say, what rules am I going to use? The product rule is going to dominate this one because it's multiplication. So remember, how do I set up product rule problems? I've set f of x and g of x, and then I take their derivatives. F of x, g of x, take the derivatives. Dylan, yes, sir. Did you give your brother the homework, by the way?
Yeah, I did.
Okay, good.
I think you might have sent out the wrong.
Did I send out the wrong link?
Yeah.
Oh, let me check.
I think.
Because we got a text from like last period.
Yeah. Of the homework.
That said fun work.
Oh, yeah, that is your homework. Yeah.
Oh yeah, have you printed out my linear algebra test?
Yes. Do you want it right now?
Yeah.
2.7b solving inequalities.
Yes. There's the correct link. Sorry. Second one's the correct link. No, give a second moment.
Okay.
Let me work this problem. I'll give them one.
Okay.
And you can start your test. Dylan, thank you for checking that. Can you check that one, make sure it's the correct one? Okay, so what's the derivative of x to the 4th? Yeah, 4x cubed. What's the derivative of secant x? Secant x tangent. Yes, secant x tangent x. Hey, why are people talking? Shh. Shh. Ben, right there. All right, so what do? We take that, the bow tie method, so dy dx, derivative of the first times the second, so 4x cubed times secant x, plus the derivative of the second multiplied by the first, so secant x, tangent x, x to the 4th. Now, I'm going to take the x to the 4th and move it up front. That's a better idea. Okay, stop and check out. Okay, so there's my derivative. I got to find it at pi over 4. This is more than likely a no calculator problem. I don't know the secant of pi over 4 off the top of my head. I don't know the tangent of pi over 4 off the top of my head. But I do know the sine and the cosine, because the really nice thing about pi over 4 is how many degrees? 45, right. And the sine and the cosine are the same what at that point? Same thing, right? They're both the square root of 2 over 2. That's the nice thing. Sine and cosine have the same values at pi over 4. They have the same value except for positive and negative at 3 pi over 4, 7 pi over 4, 11 pi over 4. So let's take a peek at that. So let's plug in. Now, I don't know those, so I'm going to convert everything to sine and cosine. Secant is 1 over the cosine. Tangent is blank over blank. Sine over cosine, right. So 4x, what did I read pi there? 4x cubed times 1 over cosine of x plus x to the 4th times 1 over cosine x times sine x over cosine x. Now, would I do this on the calculator section? Of course not. Plug in my calculator and make it work. In fact, I wouldn't even do the derivative. I would just plug it in my calculator and hit enter and be really glad I paid $140 for that calculator. In fact, I would say you actually don't even need the $140 calculator for this one. Either calculator will do this problem because it's at a point, not the overall derivative. In fact, let's even look and see what they do. I'm curious to see if they put it in secant or if they keep it as cosine. Okay, so now I got to do it at pi over 4. Let's highlight real quick. This was my derivative. This was my actual answer. This was just that answer prettied up. So that's my derivative. I got to take it to pi over 4 now. So everywhere there's an x, I'm going to replace it with pi over 4. Thank you, whoever said cubit. All I did is convert everything to sine and cosine. If you took me for pre-calculus, if you took me for honors FST, I was big on that, and this is the reason why, is I was looking forward to calculus, even though I didn't tell you at the time. I cannot memorize all that stuff, but I do expect you to have sine and cosine memorized, especially for 0, pi over 6, pi over 3, pi over 4, and pi over 2. Everything else comes from that. Now, this is kind of an ugly one. We're going to talk about how to clean it up, because chapter 3, the next chapter, we're going to have to start cleaning this stuff up, even though at this point I'm not grading you on your ability to clean it up. So as Keenan's putting his phone away, because he's definitely not getting help off the internet to clean this puppy up, let's talk about cleaning it up. Cosine of pi over 4 is what? Okay, so now I'm going to keep my fractions lined up. So this is going to feel like chemistry. So I'm going to keep those puppies lined up. 4 times pi cubed over 4 cubed times 1 over the square root of 2 over 2 plus pi to the 4th over 4 to the 4th times, okay, cosine of pi over 4, same thing, 1 over the square root of 2 over 2. Okay, what's the sine of, okay, now here's the nice part. What's the sine of pi over 4? Square root of 2 over 2. What's the cosine of pi over 4? Yeah, so even though I'm going to write it right now, that's just going to actually end up being what? Yeah, 1, right. Well, now, we'll clean up some more, but stop and check out. For your response, I cleaned it up probably one more step before I gave a final answer, but. Okay, let's take a peek. There's a 4 there and a 4 there. I'm going to cancel one of those to leave me with a 4 squared. That's reasonably nice. I actually didn't even plan the problem to do that, but that worked out nice. Okay, pi cubed, I can't make that look any prettier. 4 squared is 16. Fraction over that. Copy dot. Yep. Clean this up a little bit more. 16 and 2. So my first part of this horrible, ugly problem is pi cubed over 8 square root of 2. Okay. Oh, Michael.
Oh, yeah. Thank you.
Okay, second part, pi to the 4th, I can't clean that up. 4 cubed is 64. Sure about that? I think it's 256. 4 times 4 is 16, 64. Yeah, I think it's 256. It's to the 4th.
Oh, wait,
not to the
4th.
4th, yeah. Okay, copy that reciprocal. Okay, the only thing I can really clean up is they're both divisible by 2, so I make that 128. Okay, now let's pretend this is a multiple choice. They're not going to leave that square root of 2 in the bottom. Remember, Breebach, Kellerman, Swinghammer, Kumar told you last year, you can't leave square roots in the denominator. The only time on the AP test you need to worry about that is the multiple choice, because the multiple choice will have it simplified as much as possible. So both of these you need to rationalize by multiplying by the square root of 2 over 2. So that gives you pi cubed multiplied by the square root of 2. 2 square root of 2 times square root of 2 is 8. No, square root of 2 times square root of 2 is 2. 2 times 8 is. This will return our 256 over here. They're probably going to make a common what? 16 times what is 256? Yeah, 16. So you got to multiply the top and bottom by 16. So 16 pi cubed square root of 2 plus pi to the 4th square root of 2 over 256. The only thing they're probably going to do more is, what do these both have in common? Pi to the 3rd square root of 2 times what's going to be left over? 16 plus pi. Whew.
Can you move up a little bit?
Yeah. Now, what's the hard part? Calculus or cleaning up? Cleaning up. Yeah, the hard part's cleaning up. So don't even lose sleep. The calculus is easy. If it's a free response, we don't do any of this cleaning up. Chapter 3, we have to start setting the derivative equal to 0 and solving. So we have to go back to the glory days of algebra. Like, how do we solve equations? What are we doing? We have to solve equations. But that is probably as pretty as that puppy gets. The algebra is the hard part, not the calculus. Though. See, Keen, you're having the aha moment. The algebra is the hard part, not the calculus. Let's stop and check up. The questions on that?
It's basically just like algebra, but like you write different notations.
Yep. Yep. And let's be honest with you. If I gave that problem to Algebra 1 kids and told them to simplify that, they'd be like blank. That involves a lot of all that, and I've told you numerous times. The only reason you take Algebra 2 and pre-calc is so you can take calc. If you don't take calc, it's really not very useful to take Algebra 2 and pre-calc. No joke. All right, now I got a tough problem for you. Who's ready for a boom challenge on a Friday? You know how you found the derivative? Find the second derivative.
This one?
Yeah. Find the second derivative. So there's your derivative. Going back, there's your derivative. I cleaned it up to that. Oh, do we know how to do that yet? Oh, we don't know how to do that yet because that's got 3 things. Sorry, you can't find it. Oh, sad. Sad panda. Sad panda.
Product.
Yes, it's a product. They don't know that. They're not in Calc 3 yet. Oh, you need me for your test. You're supposed to remind me that when they were working on product. Let me give you one. Example number 2. Oh, what do we want? Easy or hard one? Hard one.
Easy.
Easy.
All right, there's the original problem. You find the derivative. That's not that bad.
Only like 5 X's.
In 3 weeks, you'll be praying for ones that are that nice. All right, who's your professor?
Abrams.
Okay, what class do you take the test for?
Linear algebra.
Is linear algebra 30, math 3130?
Yes, 3130.
Let me go print it real quick.
What do you take that class at?
UTCS.
Okay.
Yeah, you're going to be shocked, especially in a couple of years, how many kids will finish Calc 2 in their junior year of high school.
But linear algebra is it's the most tedious of
75 minutes.
math classes I have. 75 minutes, okay.
Yeah, it's the most tedious math class ever. It actually isn't that
is.
hard. Just when you're on your 14th page of this problem, it's really hard to realize you have a couple more pages still to go to finish and still find the joy in life to actually finish.
Yeah.
Remember when you found like the systems of equations you found where they met? Doing it in like 17 dimensions. You are in a really high math class. Your class is probably harder than his. His just is way more.
Oh yeah, this is harder stuff.
Mine is just
like
slower. Isn't it like according to the national average, we should be taking like pre-calc senior year?
Yeah.
Oh yeah, because look at the school up here.
No, but like
Your freshman math classes were either Algebra 1 or pre-algebra. That was the only classes we offered freshmen.
yeah, but I feel like if you're moved like 6 cities from that full, you only take the full for like suburban, like.
Well, that's what we compare ourselves to, because like kids at DCC are like, oh, I'm not very good, and like really, you've been valedictorian. Every single one of you have been valedictorian.
Yeah,
In fact, we probably would have named a hallway after you. You would have been so smart.
yeah. They should do that.
Cameron Fisk, where's my boy Cameron? Cameron's right there. He's in med school. He got a 30 on his ACT, and we had an assembly for him. No joke. He got 30 on his ACT, and we had an assembly because we'd never had a kid get a 30 or higher. What?
Thirty six is the highest score. Not a lot of people get it.
You did it.
Because no one else got that.
Like one
That was actually amazing.
thinking about it, it's not
In the United States,
It's not my head.
only 2,600 actually.
Also, when you think about the national average is 24.
Yeah, that's the average is 24. And it gets exponentially lower as it goes on. So, yeah, it's a very good score. Even the third is a good score too.
We're just not gonna talk about that. Anyway.
Oh, just because you're always like so loud and vocal.
Hold on, I'm gonna go back, to the quotient.
Yeah, that kind of
So like,
Why is it a DY?
I'm like, I almost got accepted to school lines, but my grades are
Oh,
like.
that's why.
Almost did.
No, they said
Almost
like,
went to med school, but then.
Right, let's come up and do this one.
like they want, they're like, hey.
Who wants to come up? Oh, I forgot. Okay, after this one, remind me. We're going to do that on the calculator. The previous one on the calculator to show you how to do it. Actually, I'm going to do that while you're doing it because I'm curious what it gives you for an answer.
I have it.
You already did it? Monahan, don't take away that moment of joy from me.
Grades don't.
What was the original? Grades don't matter. Who said that? They kind of did. Is anybody in my speech and debate class?
Yeah.
Okay, so get over there. My name's Chris Jimenez. Chris is, if you know DACA, you know what DACA is?
Yeah.
Chris is a DACA kid. His parents brought him here when he was about 3 days old.
What's doctor?
DACA is, so you're illegal in the country because your parents brought you here. So literally, he was 3 days old when his parents brought him across the border, brought him to America. And his parents were like fruit harvesters, so they just like go up and down the country and pick fruit. So his freshman year of high school, he started living with his aunt just so he wouldn't like have to move schools every 3 weeks when the crops moved. He was in Nat G's. I was the tech director for the district there. He was my like student assistant. He went to the University of Washington, got his computer science degree. He makes like $250,000 a year now. Works for Zillow, if you've heard of Zillow. He's one of the computer programmers. So we called him the other day, and anybody in that class? You're not gonna believe me if not in the class. So okay, Sydney Kerner was over there whining about grades, and I was like, okay, you gotta stop stressing out about grades so much. Like grades that do not measure you as a person. They are a measure of your product, not you as a person. Your product, not you as a person.
Effort.
So I called Chris, and I called him cold turkey too. I didn't even tell him I was calling. I was like, hey Chris, when you got that job at Zillow, like, did you have to send him your transcript? He's like, no. Like, did you have to send him proof you graduated? No. Did they look at your high school grades? No. It's like, so what did you have to do to prove, like, I had to prove I could work legally in the U.S., I had to prove I was a resident of the United States, and then they asked, like, me some computer programming questions. They never asked for my grades. Like, you don't realize, most jobs out of college do not ask for your grades because they don't care. Like, you're stressing about your 4.8, and that's why I'm saying, it's like, if I told you that, you're just like, oh, high school teachers, of course they don't care. Actually, we probably care more about your grades than other jobs do. But I just called Chris up cold turkey and asked him, and then he informed me that he just got a $37,000 bonus. He called me about a week beforehand because he got another job offer from a company called Porch.com. They do like apartment rentals. Really, like me and him are fairly close. We talk a lot. And he asked if you should take it. And I was like, no, he's like, well, I like my job. This one pays better. I was like, well, just go back to your job and tell him. Not only did they match the salary, they gave him that bonus on the spot, and they bought him an apartment.
Wow.
The other one was right by where he lived, so they just bought him an apartment by where they are. Like cash. So I'm letting you know, you're stressing about grades. If you get an A or a B in a college class, you shouldn't be stressing about it. You're going to be fine. Now, if you major in PE, yeah, you should be worried about your grades because there are going to be like 700 applicants applying for your PE job. If you get a job in engineering or something, yeah, you're going to get a job. In fact, it's going to be harder for you to get an internship than a job.
Yeah, no, my dad hires people for his place, and they just give them questions about like,
simple, like circuit stuff.
Mrs. Bonfield, her husband's an IT director for they do like sewage management, but they didn't ask for his transcripts.
She's like my best friend.
Isn't she so nice? Ask her one time, be like, Beckman said he worked really hard to get you to work here. I'd spend a lot.
Did you actually?
Yes, she had like 7 other job offers.
She texted me in the morning and was like, "Hey, Alyssa, I have Starbucks in my room for you. Come and get it whenever." And I was like, "Oh, thanks." She's so nice.
She doesn't buy me Starbucks.
See, I'm her TA, and I grade all her.
I'm her department chair.
I'm her TA.
Yeah, you probably won't for you. No, see, okay, so I did, just FYI, while you were doing that, I was playing with it. I did plug that in, and it does give it in cosines and sines. And notice, what did they do? They made a common what? Denominator, right? So it does just give the answer in sine and cosine, and that's what I thought they'd do, because it'd be really hard to program it with secant and cosecant. But yeah, it's actually shocking how we stress you out so much about grades in high school, and then you go to your first job and you're like waiting to hand over your pristine grades to this employer who's going to give you a job. Like, yeah, I don't see that. What do you know about programming? Where'd you do your internship at? Like when I got my job as an actuary, they didn't ask for grades. In fact, I got a job offer and a $20,000 sign-on bonus my junior year of college. All I needed to prove is that I graduated. And actually, when I got the job, they didn't actually care that I graduated. They just wanted to know I could do the work. But it was harder to get the internship with them. Like my internship was really hard to get. That was really competitive. But once I had the internship, like as long as they keep liking you, they just keep hiring you. Yep. Josh.
How did that interview go?
With?
The math teacher that you talked about?
It's today after school. That's why you have to be here by 2:55.
Oh.
Mr. Rickman,
Who is it?
did you do the problem on the calculator again? Because I didn't.
This one
Yeah,
or the previous
the
one?
previous one. Because I didn't get like it in terms of sign. So I probably
This is
could
like
have.
really easy.
Now, notice that was not actually the problem I asked you to do.
We have to-
I was just curious if the calculator would give it back to me in sine and cosine. I actually asked you to find it at what point. Yeah, so I'm going to go back real quick and just show you. Avery, I'll take a question just like.
No, that's what I.
Okay, so then you go to derivative at a point because I want to know the derivative at just that one point. So the variable's x. The value I want to find it for is what? Pi. And if you haven't found pi, by the way, if you just look down the left-hand side, it's on that screen. So pi divided by 4. Did you notice, though, you could have put in I? There's this horrible class called complex analysis that is calculus of imaginary numbers. It doesn't. So if you are going to be an electrical engineer, that's the worst class you're going to take in college is complex analysis. This totally does complex analysis too. If you ever see Arjun and Mohit in here arguing at each other like the world's going to explode, they're arguing about complex analysis and if it's better to put answers in e to the I theta or I sine plus cosine theta. Yeah, that's the class they're talking about. It actually is. I sometimes worry that they're going to fight.
No, it's like entertaining though.
Okay, so then what was my function? X to the 4th times secant x. Am I putting in the right function, Monahan?
Yeah.
Or did I just make up something?
Yeah, you are.
So notice, oh, it did. Look at that. And here's the kind of weird part about how the calculator did it. It took out pi cubed and put it in front, and it took out what else? Square root of 2 and put it in back. That's kind of weird. But there's your exact answer. Now, here's the other thing. Will this calculator do this as well?
No. Yes.
Yes, it will. It just won't give you the answer in that form. It'll give you the decimal approximation. So you don't have to have the supercalculator to do it at a point. You just do have to have the supercalculator to do just the generalized derivative, though. Sadly, that's what the CAS does.
And with the derivative at a point, you can choose what like second derivative or third or fourth derivative.
Correct, yeah. Yep.
So how did you get secant?
Secant, go to trig over on the side here, and then it brings up a little list of all the trig functions it can do. And secant is on that top row, SEC. Also, if you just type in the letters SEC, it will do the secant for you as well. Yeah. Whichever one of the two you like better. No, let's take the derivative of this. We've done yet? We're still having fun with these. Are you kidding? We didn't even do the funnest one. What's that? Okay, what rule is this one? Quotient rule. Who wants to come up and do it? Maddie Barco. Oh, Tim, come on down. Sorry. We don't judge. Okay, so what is this section? It is really just looking at the quotient rule, the product rule, the power rule, the sum rule, the minus rule, now with adding those trig functions in. So as Tim's doing that, I'll let you know. You do have a test next Thursday. This is the last stuff that's on it, though. We will just spend Tuesday reviewing for it. And I know every teacher in every class gives a test next Wednesday or Thursday, so I'm letting you know a week in advance. After that, chapter 3, chapter 2 is the test you should do well on. The BC kids took theirs a couple weeks ago, about a 20% higher average than their first test. Then it gets progressive. So chapter 2 is a lot easier. Then chapter 3 is a little bit harder. Chapter 4 is a little bit harder. Chapter 5 is a little bit harder. Chapter 6 is a little bit harder. So this is kind of the tests go like this. You definitely took the hardest test of the year on limits, and then it dips down and kind of goes back up. There's not a test that's harder than the limits test for the sheet.
That's good.
Well, a lot of the limits test was like getting to know how I grade, understanding what I'm expecting,
That's
writing the
true.
notation correct.
Also, you're still like relatively fresh out of summer. So.
Yeah.
I
And limits is the most conceptual thing you have to understand.
mostly forgot everything God taught us.
Because if it's all new,
I
it's
didn't
like hard,
know
but
anything,
if you already know what I'm gonna.
Yeah,
Yeah.
Andrew, I didn't have anything to forget.
I
There you
You
go.
didn't have anything to forget?
Yeah.
Like you brought us
There
to
you
such a
go.
level concerning like literacy and trig last
So
year.
what were you gonna do if she
I
taught?
forgot everything.
What were we gonna do if she taught calc this year?
Oh, I was gonna take it at either Pikes Peak or my dad's.
Seriously?
My parents were not having that.
I was gonna drop and take stats.
Me too.
But you're a junior.
Yeah, I could not.
So what are you gonna take senior year?
I don't know, something else.
It's finance.
I wasn't.
Business finance. Yeah, you're an 8th grader in honors algebra 2, and you finish out with business finance. What a great school you went to. Middle school leaves you like top of the nation. High school, you take a business finance. When you have account change your senior year. Yeah, great. Yeah, right. Okay, Tim, talk us through this one.
So basically, it's the derivative of the top one times the bottom one, then minus the derivative of the bottom times the top over the bottom squared, and that's that. And I just didn't simplify this.
That's okay.
Is
Do you
this
need to
allowed?
worry about simplifying at this point?
No.
No, that's fine. Can you explain, Tim, what's over here? Can you read that? Oh, that's not part. Okay.
No, that's just like the
I got it. Sorry. Now, chapter 3, we will talk more definitely about simplifying. Chapter 2, it is finding the derivative, is not necessarily simplifying it. Okay, could we find the second derivative of that? Yes. Would it be fine?
No.
No, because the top would be this whole thing. Now, if you had to find the derivative of this whole thing, what rules are you going to have to use for that?
Some difference.
Sum, product. No, actually, it'll be a difference. Whoever said that, you're right. It's a different, it's a product, and then the whole thing is a, like the entire problem will be a quotient rule. Yeah, so you have to sign it forth on the bottom. Yeah. That's a lot of work. That's a lot of work. All right, I feel like I'm done for today. Have I talked enough about velocity, acceleration, position?
No.
Yeah,
we just-
Okay, let's do another example of that one. Let's give you a particle one and talk about that. So, because the AP test loves those particle one. Can I do a sine one? Yes, let's do. Okay, okay, you have to be patient. I got to think of the implications of this one. I got to think. Okay, let's go for this. So, a particle is moving along the x-axis, which for some reason, Lynn McMullen, the guy that writes the AP test, he loves these problems. A particle is moving along the x-axis. With x of t equal to, gotta have this do something. How am I gonna have this do something? I gotta have, okay, negative x sine x. Can I have it squared? No, but I could have it, no, I can't have it cubed either. I guess I could have it squared. Okay, let's go for negative x squared. I did add a squared onto that one. Is that gonna do what I want it to? Is that gonna do what I want it to? Yes, okay. So part A, find v of t. Part B, find a of t. Real quick on your own, find a of t, v of t. V of t is the what? Velocity. Velocity tells you two things. It tells you both direction and speed. Direction and speed. What direction is it going in and how fast is it going? And then a of t, David, yes?
I have no idea.
Okay.
I don't know what's going on.
Okay. According to the boys, it's just trivial basics. Okay, so position is where you what? All right, imagine your life before calculus. Imagine your life before calculus. When you had y equals, it's just telling you the position. When you graph it, you're just saying where is it? This vertical is just moving left and right along the x-axis, so it's not moving what direction?
Up and down.
Up or down. That'd be a count 3 problem. Then we're involving multiple directions involving that. X of t is at time. Oh, jeez, no wonder.
There you go.
Wait a minute. Whoa. What?
All you physics kids. Oh, I'm so smart. It's so true. Shouldn't talk smack about you till I can do it correctly. Yes. There we go. Okay, so X of t is just telling you where is the particle at that time. That's all it's telling you is location. X of t is just telling you location. When you take the derivative of that, it's then going to give you what? Rate. When you take the derivative of something, it's asking how fast is that thing moving. Now, the nice part about velocity, when we plug a number in for velocity, we're not only going to get how fast is it going, we're also going to get what direction is it moving. Now, this particle is moving just what? On the x-axis. Take out your pencil real quick. Just move along the x-axis. What directions can you move in? Either one or what? Left or right. So if velocity is positive, it's moving to the right. Now, can it be at a negative location but a positive velocity? Yeah, it just means it's to the left of 0, 0, but it's moving to the right. X of t tells you the position. Where is it? And until this class, that's really all you can tell. We can find the slope of a straight line, but nothing else. X of t tells you where it is. V of t tells you how fast and what direction it's moving in. So part A is to find V of t. Velocity is the derivative of position. Part B then asks you to find acceleration. Acceleration is the derivative of velocity, right? So all I'm asking you really to do is find the what? First derivative and second, right? Now acceleration tells you how fast the speed is changing, but it also tells you, is your speed increasing or is your speed decreasing? So acceleration is not only going to tell you, is it speeding up or slowing down, but how fast is that? Velocity tells you which direction and how fast. Acceleration tells you, is that getting faster or is that getting slow? So kind of weird. Can your speed be increasing but your acceleration be decreasing?
Yes.
No. Can your speed be increasing and your acceleration be decreasing?
Yes.
Yes, if you're moving in what direction? This particle. What would it have to do for its speed to be decreasing and its acceleration to be decreasing? Speed decreasing and acceleration decreasing. Think about that for a second. Let me get Noah's test here. Because of course everybody waits till the last day to take it. Oh! Noah, you're an AB, correct?
Yeah.
Yep, you get an AB test. Good luck.
You can give him a BC test.
That's mean.
Yeah.
Try my best.
You gave Ashton and I AB test.
No, I gave you BC test. I just forgot to change the letters at the top.
Okay. You're trying to feed this hashtag and make us take multiple tests. Probably trying to do that.
No, but sometimes when I rewrite the versions, I forget to go at the top. Because you have one that's got like cosine to the 10,000, cosine of x to the 10,000. They don't
1,000.
get that. What's that?
For the multiple choice ones,
Yep.
you need to write an explanation.
If it's worth 1 point, no. If it's worth more than 1 point, yes. So if it's a 4-point multiple choice question, 1 point to the right answer, and then I'm expecting 3 things in your explanation.
Okay.
No.
You did go ahead, though.
Go ahead,
brother.
All right. Notice how I'm asking the same questions over and over and over again. That's so in your brain. You're asking the same questions over and over and over again. Let's call some victims here. Who looks chipper as can be? Yes, Luke. What rule is this one? It is a blank rule. Product rule. Because what's happening? We're multiplying t squared by sine. Right. So we set it up. Part A, v of t is what I got to find. But also f of x. Well, f of t, not f of x. I keep writing x where there should be a t. F of t is equal to negative t squared. G of t would be equal to sine of t. Now, don't forget, in the background, every derivative is finding a what? Limit. We just happen to know some shortcuts now to find that. Every one of these is involving a limit. Okay, what's the derivative of negative t squared? Negative 2t. What's the derivative of sine? Cosine, right. So again, bow tie rule. So your velocity is equal to the derivative of the first times the second plus the derivative of the second times the first. I'm going to clean it up just a little bit. I'm going to take the minus sign and Move it through. Okay, that is the velocity. Now, have I asked you to plug in a point yet?
No.
No, I will in a second. When I plug in that, it's going to give us both the direction it's moving in and how fast it's moving in that direction. If it's positive, it's moving to the right. It doesn't tell us anything about where it is. It just tells us what direction it's going in. So again, I haven't written this down today because I feel like I wrote it earlier in your notes, but x of t tells you position. V of t tells you what direction and how fast it's moving. A of t tells you, is that velocity increasing or decreasing? In other words, is our speed getting bigger or smaller? Now, it's kind of weird. Your velocity can be negative but increasing. Your velocity can be negative but increasing. What does that mean? You're slowing down but going to the left. Slowing down but going to the left. So in other words, you're going to the left, but you're slowing down, maybe heading to the right. If your velocity was negative and your acceleration is negative, that means you're going to the left and you're getting faster going to the left. If they contradict velocity and acceleration, that means you're getting closer to zero. If your acceleration is increasing but your velocity is negative, that means you're slowing down. If your velocity is positive but your acceleration is negative, that means you're going to the right but you're slowing down, like you might be turning to the left. Yep.
So relating this to rocket science.
Yep.
They have a rocket.
Yep.
And it's about to shoot off.
Yep.
And go to the moon.
Yep.
And they have to figure out where they need to intersect the moon.
Yep.
Feel like
Hopefully not intersect. Hopefully like gently touch. If they intersect, that's not going to be good for the astronauts.
Yeah, but that's why. Is that why they had to come up with all these new formulas and math for that? Because they had to find. Do they constantly have to find?
Are you ready for this craziness? You ready for this craziness? I'm not 100% sure if I'm going to get to it this year in your class because it's not on your AP test, but we keep going fast. I mean, we're going significantly faster than they went last year. We're almost a month ahead at this point, which to me is mind-boggling that they spent another month than we've spent on this, because at some point, like, what else am I going to tell you? So I am being cautious in how fast I'm going, because this is the first time I've taught just AB. I've taught BC several times. But if we have time at the end of the year, I will start to teach some of you some BC stuff just so you see it before. And some of you may go to a college that covers this in Calc 1. But there's a method called Euler's method. What's that movie? Hidden Figures. We watch Hidden Figures, and like the lady goes to the board, and all they have to do is they reanalyze the formula they have for gravity, acceleration, velocity, and position based off every data point they get in. And what they do is then they just make, are you ready for this? Delta X, aka H, smaller and smaller and smaller as they get closer and closer and closer, and make a new acceleration formula for every data point they get back from that space station. And that's what she did. She used Euler's method, which is a way of just closing that delta X down to be able to approximate it for just 1 point, which should feel really familiar to you, because that sounds like we're finding the what? Derivative, right? But it's a derivative of some other function. But yes, so it's constantly regenerating new formulas.
And so that's why they need to use like computers and stuff. They're not just
Yes, and that's in fact why they were so excited when they could fit a computer in a single room. Because if you remember, okay, let's connect this to Mohit. So since we're talking off topic, we might as well get as off topic and connect all the dots we can. Mohit's in a class called linear algebra. Linear algebra is like 17 variables with 17 equations. Okay, yeah, yuck. Yuck is the right word for it because it takes for freaking ever. It's the class that you really just want to give up on this and be a PE major. Like my PE majors are doing yoga. I'm on page 16 of this one problem, and I've got 4 of them to do. Moment of pause. But what you would do in the olden days, like in the 60s, is you take this card and you plug in the coefficients for every variable by literally punching it out. Remember Al Gore versus George Bush? They had the punch cards that the computer didn't read right, and it led to the election not being decided instantly. That's what you used to have to do. And you plug this big card into a computer. You'd come back in like a day or two, and it would spit out the answer to your equation. Now, you could imagine if you've got people like on a rocket up in space, that's not really useful. Like, oh, darn it, we're off. They're going to get close and then shoot off into space for all eternity. So when they cut those computers' processing time down to where it could spit it out and then just in a few minutes spit out an answer, that's when they could finally start like legitimately thinking about going to space. That was the thing that led us to the space. not really any other advancement. It was just the computers could kick out answers quickly. What did they kick out answers to? These linear systems. What were these linear systems doing? Analyzing the rate that the space, like the lunar module, needed to go at to actually like gently hit the moon instead of like cascade off forever. So you'll see in that movie, like they're punching out cards, and that's what they're doing. What Mohit's doing in class right now, punching it in, getting it out. Now, of course, this calculator you can buy for $100 that fits in your back pocket can do it in nanoseconds. But yes, that's exactly what they were doing, which we may, if you don't get it this year, we'll definitely get it next year. It's called Euler's method. It's just a way of approximating.
E to the I pi or
E to the I pi is just a way of representing imaginary numbers in the imaginary plane, but it's way easier to use properties of E than it is to actually find it without it. Just makes it easier. Okay, we found that. So then we got to find A of t, which, why would you care about that when you can learn about, random stuff on the internet? But okay, if we find A of t, the problem is now we have what? Two products, so we have to do this twice. This is where I showed you the bow tie method initially, but eventually you get to the point that you've done it enough that you don't have to write that out every single time. It's just the derivative of the first times the second plus the derivative of the second times the first, which just saves you having to write this out several times when you get problems that you can do it more than once. So I'm not going to write it out this time. So I'm going to be a little bit of a risk taker for the acceleration. So my first thing is -2t. My second thing is sine. So the derivative of the first is -2 times the second plus the derivative of the second times the first. Notice I just moved the first out front. Okay, plus. Now I'm going to bring this down to another line. The derivative of the first thing of this one. So I'm going to minus that whole thing. Minus 2t cosine t. Plus the derivative of the second, which is going to be trouble because that's going to be a negative. So negative sine t squared. So notice what I did. I moved the negative out front so I didn't forget about it because I feel like that's where I'm going to make a mistake here. The first thing is t squared. The second thing is cosine t. Derivative of the first times the second plus the derivative of the second times the first. Clean up a little bit. I've got -2 sine t minus 2t cosine t. Distribute the negative. Oh, look at that, minus 2t cosine t. It's like we just wrote that. And then negative makes that a positive, t squared sine t. Clean up a little bit more. I've got that and that. Those are actually like terms. You've got -2 of this and -2 of that. So that gives us -2 sine t minus 4t cosine t plus t squared sine t. Hot dog. Questions on that? Does it matter what order you write these in? Okay, stop and check out questions. When we talk about tedious math, this is what it, like the individual parts of this are not that hard. It's just putting all the parts together correctly. It's more challenging because there's a lot of parts. Okay, so now let's do some fun. Let's find v of pi and a of pi. And what does that tell? Okay, no, that's an easy one, people. Don't give me the... Pi's an easy one. I could have given you pi over 6. Okay, I could have given you pi over 6. What's a v of t? What's a of t? Good news. What's cosine of pi? -1. What's sine of pi? 0. So anywhere there's a sign, it just goes. There you go. That's why it's nice. Pi over 6, nothing would go away. It'd be ugly. Okay, so v of pi. Let's plug in pi. Where's our v? Our v is up here. Good news. What's the sine of pi? 0. So that goes away. What's the cosine of pi?
-1.
So -1 times -t squared. So negative pi squared times -1, which gives me just what?
Positive pi squared.
Pi squared. That tells you that it's going what direction?
Right.
Because velocity is positive, it's moving to the right. And what's its speed? How fast? Pi squared. So it's moving to the right. It's pi squared. Imagine a cop pulls you over. You'd be like, no, I wasn't going 60 miles an hour. It's going pi over 2. I was going pi squared, and the cop's going 3.14 times 3.14. Yeah, just go. Okay. Okay, questions on that? So, two things, because I know some of you like easy rules. If velocity is negative, it's because these x-axis problems are going to come up all the time. If velocity is negative, it's going to the left. If velocity is positive, it's going to the right. Whatever the number is, the absolute value, that's how fast it's going. Acceleration, I'll go in just a second. Let's go to acceleration here. Actually, let's take questions on that. That's a lot of information. Questions on that? I will just let you know, they love these x-axis problems. They do not want to reward memorization. They want to reward understanding. And these kind of have you figure out, if you're just moving in one direction, like it's only 1D motion, what does velocity tell you? What does acceleration tell you? And again, kind of weird, but think of your entire life in math up to this class. It was all about position. Y equals tells you where. It does not tell you how fast or what direction. Y prime tells you how fast and what direction. Y double prime tells you is that speed increasing or decreasing. Okay, let's plug in A. Any pi, anywhere there's a pi sign is going to be what? So gone. All we got to worry about is this. Plug that in. What's the cosine of pi? So -4 times pi times -1. Negative times a negative is up. 4 times pi is 4 pi, which tells you that the speed is increasing at 4 pi meters per second squared. So this is telling you not only is it going to the right, but it's going to the right faster at this point. In other words, its speed is increasing at this point. So we would expect its graph to be sharpening out if we looked at it a y equals equation. So it's going to the right, and it's going to the right faster. That's like when you're in soccer. You're going towards the goal, and your speed is getting faster as you're getting closer. Like as you're going to the right farther, your speed is increasing. Now, do we talk about anything about position? No, we plug it into x to get its position. Like, where are you? X. How fast are you? V. Is your speed increasing or decreasing? A. Am I going to the right or to the left? V. Questions? Look how freaking smart you are. Look how much you've already learned about math like this year. You've been in this class for less than a quarter of the year. If I would have asked you to do this at the start of the year, you'd have been like, what? Like, I can't even read this problem. Look how freaking smart you've gotten already. The only thing that could help you get smarter is just make sure you join speech and debate. By the way, we got a student being recruited to Nebraska, and I just got a call from the coach from Oklahoma. Yeah. Yep.
Is debate like recruited like an actual?
Just like everything else. In fact, I can't wait for them to tell me where they're going to take me to dinner. In fact, I shut that off for this part because I don't know. The Nebraska coach